Hey guys, here we go with part 2 of the first section of the skeletal system, and we're talking a little bit more about the growth and kind of the physiology of what happens in the bone. So first part we're going to look at here is how bone grows as you develop. So as a baby and a fetus, as you develop in the womb, most of your bones are actually cartilage, which most of you probably knew already, but we talked about this when we talked about connective tissue, and we said that hyaline cartilage is the most abundant type of cartilage in the body. Well, there's a reason for that, because when you're a baby and you're developing, actually most of your bone is hyaline cartilage, most of that right there. As it develops and you start to get older as a fetus, like right before you're born, you have a bony structure in the middle, and you have hyaline cartilage on both ends with just kind of like a little nub of bone in the middle there of that hyaline cartilage. And as you grow even further as a child, then you're going to actually develop a bone, kind of like a cap on the bone on either end there, and that's what's called the epiphysis of the bone, which we learned last section. And this is the diaphysis in the middle. Here's the epiphysis down here. So actually, when you start to develop that bone and it starts to grow together, you still have a little plate in there. And that's what some of you may have been to the doctor and they talked to you about your growth plate. Well, this is what they're talking about, growth plate right there. It's the epiphyseal plate, which is kind of the separation between the epiphysis and the diaphysis. And that will eventually, right here as a child, it's still a little bit of a cartilage type substance. And as an adult, that'll become a complete fusion, which will end up we'll call it the epiphyseal line at that time. But you can see how you still have articular cartilage on both ends, and that's that hyaline cartilage still hanging out on both ends of the bone. And we talked about that when we talked about the different types of cartilage in your body, and that's the articular cartilage there that's giving you the ability to have movement in your joints and those bones not to rub against each other. So that's the growth process of the bone there. Here's another picture of it. So here's the fetal picture here, and here's another example of the development. So you have that cartilaginous model, and then ossification in the middle with cartilage on both ends. Then you got the full diaphysis with a little extra hard osseous structure on the two ends there, and then as an adult you end up with a full fusion of the bone. So you can see in the baby here, in the fetus, you see those dark spots there. This is the CT of that baby. You see fluid as white and you see hard substance as dark. So it's kind of like the opposite of X-ray. So here you can see the bony structures in there, but you can see all the separation between them too. So that's how that what ossification looks like. So after by birth or shortly after that, you have mostly hyaline cartilage, like we saw in that picture earlier, and it'll be converted into bone eventually. So you have the articular cartilages that cover the bone's ends, and the epiphyseal plates, which I showed you in that picture earlier. That's kind of the separation between the two ends of the bones and the middle of the bone there. So that's the process of converting bone or cartilage into bone. So that articular cartilage, like I said, stays on there forever just to keep your joints safe. And the epiphyseal plates allow for what's called longitudinal length growth, so like the length of the bones, that will allow growth to continue through childbirth or childhood until you end up getting to the point where it fuses, like I said, and it turns into a epiphyseal line. So new cartilage is formed continuously in the external face of the articular cartilage, and that is again protecting your joints and keeping those bones safe through movement. Old cartilage in the internal face of the articular cartilage and medullary cavity, which is in the middle of the bone, that's broken down and replaced by bony matrix, which is the solid structure of the bone. So there's different cells that are involved in the whole growing process of your bone. So you have osteoblasts and osteoclasts. Osteoblasts are designed to make more bone. So I always say blasts build bone. So BB, blasts build in the periosteum, which is the outside part of the bone. They add more bone to it, and they're building more diaphysis, which remember is the middle part of the bone. Osteoclasts are in the endosteum, which is in the inside of the bone, and that removes bone from the interface of the diaphysis wall. So the reason why that is because as you're constantly building new bone, if all you did was build bone, and you didn't take any away, then it would just keep getting bigger and bigger and bigger. So the osteoclast breaks down the bone so that the osteoblast can build more bone, and that makes growth in the width of the bone. So that epiphyseal plate or epiphyseal plate on either side allows for length in the growth, and then osteoblasts and osteoclasts allow for growth in the width of the bone. Oppositional growth, process in which bones increase in diameter. So this is what we were just talking about with the osteoblasts and osteoclasts. Growth of the long bones is controlled by hormones, and the ends of the epiphyseal plates are converted to bone during adolescence, and that's where that whole conversion of the osteoplate starts to fuse, and it starts to create a full solid bone. Bone remodeling is the whole process of breaking down bone and rebuilding bone. So it helps with the strength of the bone as it grows and as the body increases in size, and helps it kind of accommodate to the more pressure on the body because of increasing size. So here's another example of the growth of the bone that we've been talking about. So you got cartilage down over here in the end, and this is the epiphysis, this hard part here, and you got the diaphysis here. There's the epiphyseal plate right there, and then is the process of how the bone is growing. So here's the bone resorption happening here with the osteoclast, and the bone is being added here by osteoblasts. So that's the width of the bone growth. There are some situations where you could have some abnormal growth in bone or lack of growth in bone. So one of the conditions that causes that is called rickets. And I've told you before, when we talk about conditions and stuff, what you want to do is try and cue on particular names or particular parts of the condition that will help you remember it. So vitamin D here, vitamin D is how you can remember what rickets is, because that's what's causing rickets, is a deficiency in vitamin D. Remember, we talked about vitamin D coming from the sun, and your body making it. That helps your bone growth and keeps it strong. Fractures. You guys have all heard of fractures, and maybe some of you have experienced fractures before. There are different types of fractures. There's a closed fracture, or what's called a simple fracture. Basically, the bone broke, and it's still contained in the skin, and it's definitely still a problem, but it's going to heal. An open fracture, or what's called a compound fracture, is when the bone breaks and actually breaks out of the skin. And some of you may have had this happen. Some of you may have seen it happen. That's never good. So now you have a wound and a broken bone to deal with. So simple or closed versus open or compound. And there's more to fractures than that. But when you have a fracture, there's a couple things that you can do to help those fractures. And one way to treat it is called a reduction, which is realigning the bone and basically putting it back in the right place so it can heal itself and grow back. And that's basically what your body will do anytime it gets injured. Just like when you get a cut, it's going to heal the skin. When your bone breaks, it'll rebuild itself. But if it's in the wrong position, it'll rebuild itself in the wrong alignment. So reduction is important so that you can put it back in place so it can heal correctly. So there's two different types of reductions. There's a closed reduction and an open reduction. Closed reduction is when the bone ends are put back together into the normal position by a physician's hand. It's basically, some of you may have seen it on like TV shows and stuff like that, where they kind of pull on the bone and the person's laying on the table and it sets back into place. That can be done like that, or there's an open reduction, which needs surgery, and you have to actually cut open the leg and put something in there to cause it to stay in position, like pins or screws or plates or those kind of things. So 2 different types of reductions there. So after a broken bone's reduced, it's immobilized, then you put the cast on it and it's going to heal eventually, and it takes 6 to 8 weeks for a bone to heal. So if you break a bone, you're out of commission for at least 6 weeks. Most people, it takes 6 to 8 weeks for that bone to grow back. And once you do that and you have that cast on there, then you're going to have to kind of rebuild some muscle afterwards, because you're going to have atrophy in the muscle, which we've talked about before. How remember that principle of if you don't use it, you lose it. Well, if you have a cast on a muscle, it's not being used very much, so you're getting a lot of atrophy, and you have to work to grow that muscle strength and growth back after your bone has healed itself. So the repair of a bone fracture involves 4 major events, just like when we talked about in the skin, that healing process that you needed to learn about, how the skin rebuilds itself when it has a wound. Same thing with the bone. As it builds and it heals itself, it goes through 4 different stages. So the first stage is a hematoma is formed. Those of you who have taken medical terminology, you know that hematoma, hemat means blood, and oma means tumor or swelling. So in this case, it means swelling. So hematoma is swelling because of blood, so blood rushes to the area, basically is what that's saying. And the point of that is because blood is healing. It has a lot of nutrients and oxygen and healing powers in it that will help that healing process to start. Second stage is the break is splinted by fibrocartilage callus. So this is kind of like a scab building up on there. And we talked about in the skin how you had those fibroblasts that moved over into the wound to help with the healing process. That's the same kind of thing that these fibrocartilage particles in the callus are doing here. It's building some bony matrix and collagen, just like the fibroblast did in the skin, and it's that's speeding up that healing process so that the bone can start building itself back up again. And the bony callus is formed, and this is really like the scab that would build up on your skin. You got osteoblasts and osteoclasts coming to the area. Remember, osteoblasts are building, osteoclasts are breaking down. So basically, the osteoclasts are taking away old, bad bone particles, and osteoblasts are building up new, healthy ones. The fibrocartilage is continuing to build that bony callus, so you get a hard substance. And then number 4, over the next few months, the bony callus is remodeled, and it creates this patch, this permanent patch on the fracture site. Now that spot where the bone broke will never be exactly the same as it was before it broke, but it's the next best thing. So it's still going to be functional, it's still going to work well and be strong, but it'll never be like it was initially. So those 4 stages, those are 4 stages of the bony healing when bone breaks. Just like in the skin, we had those 4 steps to wound healing. You should have learned those in the skin. Now there's 4 steps to bone healing. You're going to need to know those too. So you got hematoma formation, fibrocartilage callus formation, bony callus formation, and then finally bone remodeling, which is basically building new bone and creating a new patch where that broken spot was. So this is part 2 of chapter 7, first part of skeletal system. Make sure you're going through and reviewing this information every day.